Hello grade 10s. This is the lesson for Tuesday, April 28th, my sister's birthday, just in case you were wondering. So what I would like you to do first is, as usual, the first 5-minute question. And again, I really encourage you to do this without seeing my answer. And if you're going to do it, which you should, I would like you to do it now. Okay, so hopefully you paused it and tried it. So here comes the answer. So first of all, we're asked for the vertex. So the vertex is a point, so we put it in brackets. To get the x value, that's going to come right from here. But whenever stuff's in brackets with this quadratic stuff, we actually change the sign. So this is 3. And to get the y value of the vertex, it's whatever number is at the end here. And if there's nothing here, it's 0. In this case, it's plus 5. Okay. So to get the step pattern, number 2, the normal is 1, 3, 5. I keep getting these pop-ups. 7, 9, 11, 13, 15. You can just keep going. And this happens when a equals 1. In our case, a equals -2. Okay, so in our case, a equals -2. And in order for us to get the new step pattern, we multiply every single one of these times -2. This looks like it says x minus 2, but it's not. It's times -2. So 1 times -2 is -2. 3 times -2 is -6. 5 times -2 is -10. And 7 times -2 is -14. So there's the step pattern. And it opens down because a is negative. So number 3 is the y-intercept. Now, I didn't exactly show you how to do this necessarily, but we know that the y-intercept happens when x equals 0. And this has been the case since grade 9. So we go y equals -2, bracket. And then where we have an x, we put in 0. So 0 minus 3 squared plus 5. And now we do order of operations. So first in brackets, 0 minus 3 is -3. You still have the plus 5. Don't forget the squared. Now we do exponents, so -3 squared is -3 times -3, which is 9. Now be careful, because some of you on your calculators, if you push -3 and then squared, it's going to square the 3, but it's going to ignore the negative. So make sure you put the -3 in brackets and then square it. And then plus 5. So now I multiply, so -18 is -2 times 9 plus 5, and y equals -13. Okay, and the last thing we're asked for is another 4 points on the curve. Okay, so number 4. To do number 4, you might need today's lesson for this. So to do number 4, first, I'm going to plot the vertex at 3, 5. And then I'm going to use the step pattern. So to do that, I'm going to go over 1. And the first step is down 2. So 1, 2. And then over 1. And then down 6. 1, 2, 3, 4, 5, 6. Okay, so this first point, if we go over 1, we're at 4. And if we go down 2 from 5, we're at 3. So 4, 3. And then if we go over 1, we're at 5. And then down 6 was the next step. So from 3, we go 2, 1, 0, -1, -2, -3. So this is 5, -3. And we can keep going over and down, but remember, we can use the axis of symmetry. Okay? And we can go the other way. So if we go the other way, instead of going to the right to 4, we go from the left to 2, and then we go down, and we'll be also at 3. So this is going to be 2, 3. And then we go over, so we go over from 2, we go left 1, so this point's going to be 1. And because of the axis of symmetry coming through here, the y value will be -3 as well. And we can check this in Desmos. So -2, so y equals -2, x minus 3 squared plus 5. Okay, so let's see, we've got 3, 5, 4, 3, and that checks out. And then we've got 5, -3, so right there. And then over here we've got 1, -3, and 2, 3. So that works. If you couldn't do number 4 or number 3, no worries. Number 1 and 2 are the important stuff from yesterday. So as long as you can do number 1 and 2, you are good to go. Today we'll look more at the graphing part. Okay, so here we go. I'm going to sort of summarize yesterday. Again, I kind of did this already yesterday, but I'm going to do it one more time here. So first, let's talk about what each parameter does. A, if A is negative, parabola is flipped upside down or reflected in the x-axis. If A is larger than 1, parabola is stretched, let's say vertically stretched. That's the way your textbook will probably say it. Okay, and when I say larger than 1, I mean like 2, 3, or -2, -3, ... So 2, 3, ... or -2, -3, ... So if A is less than 1, so by that I mean like 0.5, 0.25, ... Or it could be -0.5, -0.25, ... So less than 1 doesn't mean like 0, -1, -2, -3. The negative, the sign, just tells us if it's upside down. And then we just look at the number, ignoring the negative if it's there. Okay, so H tells us the x value of the vertex, or it tells us about horizontal shift. So that's basically moving the parabola left and right. I'm just going to say here, be careful with the sign. And then K tells us the y value of the vertex. Or it tells us about vertical shift. And in this case, the sign is normal, so no need to be careful. And again, remember, you can pause and write down what I'm doing. You can like drag your window over, sort of like this, and then you could have Desmos here or your note here, so that you can do 2 things at once. Okay. Next thing, use transformations to sketch this graph. Okay. So you're going to notice that this is not in your note. Okay, so this is not in your note, but it's just an example that I want to do. So the order that your textbook does transformations might be different than the order that I do it. What I do is I do it in the order that makes sense for graphing. Okay, so the first thing I'm going to do, so step 1, this isn't a transformation, but I'm going to sketch y equals x squared. Okay, so it starts at 0, 0. Over 1, up 1, over 1, 1, 2, 3, over 1, 1, 2, 3, 4, 5. And then I go the other way, and I reflect these points across the axis of symmetry. I don't even know that I have to draw the curve in necessarily, but I'll do it just because. But again, you don't need to. unless I ask you to sketch x squared first. You don't have to draw it, but I think it's helpful. And then, so step 2, plot new vertex. And in this case, the vertex is 3, -8. So something else that you could do here, if you had a way to do it, is you would move this curve. Let me group these together. You could move this curve right 3. 1, 2, 3. It's not liking this. And then down 8. So okay, and that would be the first step. And then you would apply this 2. So you would do the vertical stretch. But instead, what I'm going to do is first I'm just going to plot the vertex. 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then for me, step 3 is going to be, not sure why that's blue. Step 3 is going to be use a value to get new step pattern. Remember, the original is 1, 3, 5, 7, and in this case our A value is 2, so we multiply each of these by 2. So 2, 6, 10, 14. And then my last step then is to use step pattern to get more points. So from the vertex, I can either go left or right. And because these are all positive, I'm going to go up. And in this case, I'm going to go over 1, up 2, over 1, up 6, 1, 2, 3, 4, 5, 6. And then I'm going to go over 1, up 10, 1, 2, to here. Okay. And now I could say step 5 here. Reflect points across axis of symmetry. And of course, the axis of symmetry for this one and any parabola goes right through the vertex. So this point hops across, this point hops across, and then I go over 1, this point hops across. And then the last step, which I'm not going to write down because it should be obvious, is to draw the curve. Whoa! Really hard to do on this graphics tablet. And I want at the vertex it to be a curve. I don't want it to be like harsh lines. So that's good enough. Okay. So that's essentially the lesson for today. How to graph one of these. We are 13 minutes in. I'm going to do a couple more examples. People have asked for some extra examples. So let's go ahead and first we will talk about the transformations, which we kind of did yesterday. So I do the vertex first. I think your textbook does the A value first, or the stretches and compressions. So the vertex in this case is -3. Sorry, I don't know why I said -3 there. -4 and -3. So the vertex is -4, -3. So if the vertex is -4, then I can say that parabola has been horizontally shifted 4 units to the, I want you to think, is it left or right? It's left, because that -4, negative goes to the left, and vertically shifted 3 units, and I want you to think, is it up or down? It's -3, so it's down. All right, we're almost done. So 2, parabola has been reflected in the x-axis because A is negative. The reason I do the little apostrophes or the this sort of half quotes there is just so you don't think I'm saying the word like because is negative. It's because a is negative. And then finally, parabola has been vertically compressed by a factor of 1 over 2 or 0.5. Okay, so that's it for the transformations. I'll give you one question on the test probably where you have to write this stuff out. Otherwise, you just have to know what happens. So the vertex moves, and then the step pattern gets cut in half, and it flips upside down. All right, so write the equation of a parabola that matches each description. So the graph of y equals x squared is compressed vertically by a factor of 1/5, and then translated 6 units down, or vertical transformation 6 units down, whatever. It's all the same, really, or shift. There's lots of ways to say it, but it all means the same thing. So the compression or the stretch is always the a value. So in this case, a equals 1 over 5. And if it's going down, that's going to be our k value at the end, and it's going to be -6. So our equation is going to look like this. So remember, the default is y equals a x minus h squared plus k. We can see a is 1 over 5. So y equals 1 over 5. And then in brackets, x minus h is going to be x minus, I don't see any mention of a horizontal shift or moving left or right, so I guess it's 0. And then I square it, and then k is -6. Now, there's a better way to write this. What is x subtract 0? And the answer is just x. So this is 1/5. And then x, and I can put the x in brackets, but if it's just an x, I don't have to, so I say x squared, and then I say -6. So this should be a parabola that moves really slowly or is really fat. So y equals 1 over 5. And then you got to push over x squared. So there it is. Let me compare it to x squared. It's a lot fatter, this red one, but it hasn't been shifted yet. So then we say -6. And there it is. It's fat and it's been moved down. Okay. The graph of y equals x squared is reflected about the x-axis. So if it's reflected about the x-axis, we can say a is negative. If it's been stretched vertically by a factor of 6, we can say a equals 6. But because a is negative, we know that together a equals -6. Okay? And then it's gone 3 units right. So if it's going to the right, that means that h is positive, so h is 3. And then if it's going up, we know that k equals +4. So let's write the equation. Y equals a x minus h squared plus k. A is -6. H is 3, so it's x minus h, so x minus 3. Now if h was -3, it would be x minus -3, and that double negative would make this positive. And then k is 4. Don't forget the square. So if we sketch this, a is -6. So it's going to be upside down, and it's going to go real fast. And then x minus 3 squared plus 4. So the vertex is 3, 4. There it is, right? +3, 4. It's upside down. It's upside down. And this 6 means it's been stretched a lot. So it's going real fast. It's real skinny. It's upside down. All right. I'm almost done. Here are the steps for graphing. I did this in the opening question, and then I did it again, so you probably already know how to do it. I'm almost 20 minutes in, and I want to keep these as quick as I can. So step 1, plot the vertex. Step 2, multiply the step pattern. Step 3, plot the points. Here we go. 3 examples, and if I'm not mistaken, that's it, and then you have some homework. Remember, help session Thursday, 1 o'clock. All right, so this will be the red curve. So, vertex, I change the sign, so -2, 4. So -2, 4. And then the step pattern equals, so remember normally it's 1, 3, 5, 7. So if I do 1 times a half, I get a half, or 0.5. Half of 3 is 1.5. Half of 5 is 2.5. Half of 7 is 3.5. And a is positive, so it's still going up. So from here I go over 1 up a half. Over 1 up 1.5. Over 1 up 2.5. And that's a lot of points. And then I reflect these points over the axis of symmetry. So I just go over 1 each time, and then I go up to the same level. And there it is. Okay, so the red curve is right here. So let's double check. The vertex should be -2, 4. It is. And it should be a bit fat. And it is. Okay, next one. This will be the blue curve. So the vertex equals, we change this sign to negative. So -4, -3. The step is normally 1, 3, 5, 7. We just multiply each step by 2, so we get 2, 6, 10. And then 14, but I don't think we'll be able to fit that. So now we go over 1, up 2, over 1, up 6, that'll be here, and I can't go up 10, so I'm done. Except I got to reflect the points across the axis of symmetry, which goes through here. So I go over 1 to the same level as this point, and then over 1 and up to the same level as this point. I draw my curve. And I'm done. Okay. Last one here is going to be purple, I guess. So first, the vertex. I change the sign on this number in here to +3 and 6. And then I do the step. It was 1, 3, 5, 7. Each number gets multiplied by -3. So -3, -9, -15, -21. I won't be able to fit all of those, right? It's a 10 by 10 grid. So to do this, I go over 1 and down 3. 1, 2, 3. Over 1 and down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I go over 1 and down 15, but I don't have enough room. I can imagine my axis of symmetry right through here. You don't have to draw it, by the way. I just draw it because I think it makes it easier to see what's going on. So from the vertex, I go over 1, and then I go to the same level as this point. And then I go over 1, and I go to the same level as this point. And then I draw my curve through. And then we'll look at it and make sure it makes sense. So first of all, A is -3, so it should be upside down. It is. It should be skinny because 3 is bigger than 1, and it is pretty skinny. And then the vertex should be 3 and 6, 3 and 6. So my answer makes sense. That's it. If I went too fast, watch it again, slow it down. You can also always look up on YouTube for other examples from other people. Khan Academy, I think it's Khan, does a lot of great math videos. A lot better than mine, I would say. So feel free to watch those. And just like on YouTube, look up graphing vertex form parabolas, and you'll find just a ton of videos. In fact, let me check it out. So graphing YouTube, graphing vertex form parabolas. And there you go. First result is Khan Academy. His is 3 minutes and 13 seconds. Much more to the point than mine, but probably only one example. And then it just keeps going and going and going. Okay? So there's a lot of examples of people doing this. This Brian McLogan guy does a lot of math videos as well. So if you don't like listening to my voice, you could watch those. I do encourage you to watch mine because I might put something in a lesson that they don't. And if you miss my video, then you'd miss that. Here's your homework. I had a few people say, stop giving us so much homework. Remember, the homework is not, it's not marked, first of all. I don't consider it mandatory. I consider it sort of, if you need the practice, then practice. And the other issue you might come across is that you don't have graph paper. And if that's the case, let me sort of show you what I'd have in mind. So if you didn't have graph paper, then maybe it looks like this. Okay? So let's say I'm going to graph this equation here. Then I would do this. Okay? So -4, -3, and I'd say -4, -3. And then my step pattern is 2, 6, 10. So I would go over 1, up 2, over 1, 1, 2, 3, 4, 5, 6. And I do this. Draw my curve. And then what I would do is I would just label these points. So over 1, up 2 would be -3, the x value. And then up 2 from -3 would be -1. And then this one here, if I went over 1 to the left, it would be -5. Y value is the same as this point. And then from here, I'd go over 1. So this would be -2. And up 6. Up 6 from -1 would be 5. And over here, if I went over 1 again, it would be -6. Up 6 again would be 5. So this is a perfect graph because you've labeled everything. Okay? So yeah, don't worry about not having graph paper. If and when I test you on this, I'll give you grids to use. Okay? So just keep doing your best. Remember, the goal here isn't necessarily, I mean, for some of you, sure, a great mark is awesome. And it feels good, and it looks good on your report card, and maybe you get some ice cream or something in June. But more importantly, you need to know this stuff for grade 11 when we're, presumably back in school. So just keep learning this stuff, and that's what's important. At the end of the day, you should get through this course and hopefully be ready for next year. So keep it up, folks. Ask me questions and come to the Google Meet Thursday at 1 p.m. I'll post the link around lunchtime. Just because I can't have people in there when I'm not. We're not allowed to have students sort of in a thing created by us if we're not there. Kind of like in class where we're not supposed to just like give you some work and then leave for the period. All right, folks. Good luck with this stuff and ask me any questions if you have them. I can post additional examples or videos. Here's the homework one more time.